Section 6.8 Big 1, which is on the binomial theorem. Today we're actually focusing on Pascal's triangle, which is a pattern that was observed when expanding binomials. So to save us some time, so we didn't have to sit here and FOIL all of these examples, I've done them for you. And you can just share what we have happened as we have done this one. So you can see the first one is the quantity x plus 1 to the 0 power is 1. That's an exponent rule that we learned back in Algebra 1. Anything to the 0 power is 1. So 5 to the 0 power is 1. 273 to the 0 power is 1. And whether it be a binomial or an actual number. And then if we were to take x plus 1 and raise it to the first power, that would give 1. If we were to take the quantity x plus 1 and raise it to the second power, you would have to expand it first to be the quantity x plus 1 times x plus 1. And then normally we would FOIL this. This happens to have been done for us by giving us x squared plus 2x plus 1. Same thing with the third degree. They expanded it to be 1, 2, 3 of those quantities. And then typically we would FOIL 2 of them. And then distribute all of this stuff. Okay, and then combine our like terms with the did for us. And what we're going to do is we're going to observe a pattern with the coefficients, which is going to help us discover Pascal's triangle. So you can see the fourth degree one, wrote it up 4 times, distributed, FOILed, etc. to get this answer. Okay, so Pascal's triangle is a triangular array of numbers with the coefficient of the binomial expansion. Okay, so again, anything to the 0 power is going to be 1. And we are only looking at the coefficients for the expansion. So looking at what we had for the x plus 1, this was really 1x plus 1. So we would have 1 as our coefficient, 1 as our constant. Looking at the next one, x plus 1 squared, this would be 1, 2, and 1. The next one, our cube, was 1, 3, 3, 1. And next, and the last one that we have is our fourth degree, which is 1, 4, 6, 4, 1. Okay, now we want to look for a pattern because we don't want to have to actually do this work every time. Like if it were x plus 1 to the 10th power, you would have to FOIL and distribute a lot of times and probably take a whole paper of work. So does anyone notice a pattern in Pascal's triangle that could help us come up with the next row of coefficients? Great. Yes, so a lot of people can come up with this part, 1 and 5. We can see that the outside border is always 1s on both sides. And a lot of students will notice this because the row is like diagonal, 1, 2, 3, 4, 5. Also, this is pretty much always matching up with our exponent, so this would be 5 and 1. Well, so close. No, not 7. It's 10. 10. So some people in first and second period were saying, oh, it goes 1, 3, 6, this has to be 9. It's like what they were coming up with. But the way the Pascal's triangle works is you're actually summing together the two numbers above it. So 1 plus 1 gets me 2. 1 plus 2 gets me 3. 2 plus 1 gets me 3. 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. So if we were to continue this pattern, we would have 4 plus 6 is 10. 6 plus 4 is 10. And you can see that the 5 and the 1. You do have to remember that there are 1 borders the whole way down the 2 sides. Now it's up to you whether you want to continue this on your paper here, or if you want to flip to the handout, because this one has more rows in it. And so I'd rather, this way you also don't have to flip back and forth on the notes and the one. So This one again, you are going to have to memorize the Pascal's triangle. Not really memorize it, memorize the pattern. So as long as you remember this starting point, which is 1, 1, 1, the rest of it can be found using the sum. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, and always the outside orders are 1s. And I'd like you guys to go ahead and continue. You may want to use a calculator when you get down to like the bottom rows because they get into like the 400, 500. So I would like you guys to complete that. So on the test Friday, I'll give you a blank Pascal's triangle. I think I only do up to row 5, but you'll fill it in, remembering the rule, and then you can use it to apply to the problem. I won't give you anything with a really big exponent just because of time. But in our homework, we will see some, like a kind of large. And it may be beneficial for you to also add to your sheets that this starting point, this is really row 0. I know normally we think that's the first row, that's row 1, but it's row 0. And that's because this represented a plus b to the 0 power. This would be considered row 1 or exponent 1, row 2, exponent 2. Again, also, whatever the number after the 1 is, that's also going to match your exponent. So that's another way you want to remember it. But magic, here it is. If you're not done, keep going. But when you are done, I'd like you to check your last row, because if your last row is wrong, then the rest of it's wrong. But if your last row is correct, then all of the other ones have to be correct, because you used the previous row to get that row. So take a look and see. I think on the homework, the highest that they get to is the 8th power. But obviously, this could be used for anything. You could even continue it if you would so choose. Yeah. I figured the numbers would be too big. So they would have gotten into the thousands. So what is this going to be used for? It's going to be used so that if I wanted to expand something that was quantity to the 8th power, let's say, I wouldn't have to actually write out x minus 3 8 times and FOIL 4 times and then distribute a bunch of times and use like a whole paper. We will be able to shortcut it using the fact that we know these are the coefficients. We also know that when you expand a binomial into standard form, it's going to be in descending exponent order. So it'd be like x to the 8th, then x to the 7th, then x to the 6th, and so on. Okay, so we will take a look at 3 or 4 examples today where we're asked to expand using Pascal's triangle. Again, I'll come back to this at the end of class if you don't have it. We're only going to need up to row 8. I know many of you are done, but if not, we'll give you time to copy that at the end. So the directions here are to expand using Pascal's triangle. Okay. So we would first of all want to look at the fact that this is exponent 5, so we would go to row 5, and we would read along our coefficients, which were 1, 5, 10, 10, 5, and 1. And that's what we use Pascal's triangle to get. Now, because we have two variables, that means we're going to have two variables in our equation or our expression as well. We're going to have a to some power as well as b to some power. Okay, so we'll start with our coefficient, 1. Now, standard form is in descending exponent order, so we would start out with a to the 5th and b to the 0. Together, the sum of these two exponents have to always get you back to 5. Now, as I continue to write out the polynomial, the a variable is going to continue to decrease as the b variable's exponent continues to increase. Okay, and still including our coefficients. So we'll have plus 5. This will become a to the 4th. And then the b is going to increase 1, so b to the 1st. 4 plus 1 gets me back to 5. Okay, take our next coefficient, which is a 10, so we'll have plus 10. A to the 3rd, b to the 2nd. Again, decrease the a, increase the b. Our next coefficient is also a 10, so we'll add 10. A squared, b cubed. 2 plus 3 gets me back to 5. And continue on your merry way until we get to the end of this. So we have 5, a to the 1st, b to the 4th, and lastly, plus 1, a to the 0, b to the 5th. Now, typically, from now on, you're not going to write anything to the 0 power, because we know that anything to the 0 power is really just 1. You also don't need the 1 exponent if you don't want to. But if we were to simplify this, our answer would be a to the 5th plus 5, a to the 4th, b, plus 10, a cubed b squared, plus 10a squared b cubed, plus 5a b to the 4th, and plus b to the 5th. So again, typically we'll just not write the b to the 0 so that we don't have to repeat all of that work. But I like to show it in the notes so that you see it for the first time and why that does kind of disappear. Okay, so the next one's similar, so it's going to be a lot longer, right? Because the 8th row of Pascal's triangle has more coefficients or more terms. So looking at our 8th row of Pascal's triangle, it goes 1, 8, 28. What's next? 50. Then 70. And then back down to 56, 28, so on. Okay, so you don't have to write that down on your homework because you'll just be looking at your Pascal's triangle. But that'll be our 8th row. So the same concept applies. We're going to go ahead and start out with 1, a to the 8th. Technically, it'd be b to the 0, but I'm just going to leave that off. 0 and 1. Plus, next coefficient's 8, so that would be 8. A to the 7th, b to the 1st. Plus 28, a to the 6th, b squared. And continue that out. If you do run out of space going across the page, you can drop down onto another line of work. Usually I indent it, I don't know why, but just so you don't think this is another question answer. And that's kind of a continuation. So also notice if it is one of the rows that has like a largest number, not a repeating, you'll notice that that also occurs when the variables are having the same exponent. So when it reaches that high point, which is 70, that's when these match. And then we would also continue plus 56 a cubed, b to the 5th, plus 28 a squared, 6, plus 8a, b to the 7th, and then lastly would be plus 1, b to the 8th. The only way that these can actually get harder is when there aren't two variables. Usually within two variables would be the hardest. Right? Does it add up? No, the exponents? The exponents will always have to add back up to the total. Yes, it does. Now, down here, the difference between the first examples and these two, we only have one variable, okay? And we have a subtraction sign. All right, so we are going to let, essentially the A will be our X. But instead of putting B into our equations, we're actually going to put a -2. And I would use parentheses around it. And this is because the binomial has a subtraction. So it's almost like X plus a -2. So we're going to expand it again using Pascal's triangle. This is my fourth row. So that would be my 1, 4, 6, 4, 1. Hopefully I picked a small one, right? A line of work. So it's kind of like the same, but instead of putting a b, we're going to have a -2. And we're going to have to apply exponents to that. So we'll have 1 x to the 4th, technically -2 to the 0, which you could choose to write or not write, plus next coefficient is 4. Decrease your x exponent to be 3. Increase your -2 exponent to be -2 to the 1st. Continue on. Next coefficient is 6, so we'll add 6. Decrease the x exponent to 2 and increase the -2 exponent to 2. Next coefficient is 4. That'll be just x to the 1st and -2 to the 3rd. And last but not least, we'll have plus 1 x to the 0 power, technically, times -2 to the 4th. Now, what makes this one a little bit harder is you actually need to go ahead and find the value of each of these exponents before we move on. So -2 to the 0 power, again, that's just 1. -2 to the 1st power would be -2. -2 to the 2nd power, -2 times -2, which is a positive 4. How about -2 to the 3rd? -8. Okay, so when you raise a negative to an odd exponent, it is going to stay negative. Okay, and last but not least, we have -2 to the 4th, which would be again -2 times -2 times -2 times -2. So that means 4 times 4, which is a positive 16. You now need to multiply the coefficient that was there by the number that we found. So our pattern is no longer going to say 1, 4, 6, 4, 1 because of the -2 in its exponent. So we'll have x to the 4th plus, we have to multiply the 4 and the -2 together. So I shouldn't have written a plus sign, actually. I'm going to erase that. Now we get plus and negative, we don't want double signs. We have 4 times -2, which is a -8 x cubed. The next one, we have a positive 6 and a positive 4, so that will give me a positive or a plus 24x squared. Next, we had a 4 and times a -8 will get me a -32x. And lastly, positive 1 times a positive 16 is plus 16. That's the answer. I'd like you guys to try example 4 as your closure. Notice it's similar. You are using the same row, the 4th row, 1, 4, 6, 4, 1, but you are plugging in a -3 as your b value this time. So our a is x, our b is representing a -3 when we do our exponents. So go ahead and give that a try, and we will share out our answers. in just a moment. All right, who can tell me what they got after simplifying their exponents and multiplying together? The final polynomial. Evan? Perfect. Very nice. Another thing I should also mention, if you want as a way to like double check that you didn't mess up the negatives in any way, these should alternate signs. If it's a negative in this side of the binomial or minus sign, you'll have a positive, a negative, positive, negative, positive. So if you want to use that as like a final check to make sure you didn't mess it up. The homework is on my teacher page, and I can pull that up on the board right now since we have a few minutes left. You'll see that you are completing several with your Pascal triangle. And then I did put on a mixed review question back from 6-2, just finding your relative max and then your zeros of the function on the graphing calculator. Just to help us start reviewing, remember our chapter test is Friday and it will be 80 points.